There's one more day. So I hope I will try to keep it as engaging as possible for all of you. Before I start, I would like to check what is the expertise levels of your Python knowledge or statistics and numerical methods, etc. So, given that this is all lecturers and professors and research scholars, I'm expecting you have some knowledge about them. Anyone without those knowledge at all? Just put your thumbs up or anything in the chat. That should be enough. Okay, that gives me good confidence. So everyone has some knowledge of Python and statistics, etc. So, okay, there's one person. So you don't have any knowledge with Python or statistics. Okay. All right, then I will try to keep it as mixed as possible then. So let's start with that contents. What I'm going to cover today is like basics of a few things like what is data science, what is Python. They are just a couple of seconds anyway. But I'll spend more time on the four different libraries of Python. That's NumPy, Pandas, Matplotlib, and scikit-learn, which are kind of key libraries to work on anything with data analysis and data science projects. Okay, so that's it. So what is data science? Well, data science is what it's addition and extension of data analysis, you can say, where we analyze the data to find more insights, what is not visible. Okay, well, it says relatively new field, but in my opinion, it's not. It has been there for some years. It is just that we are not doing it on computers or using softwares. There weren't any readily available libraries where we can call a function and get the insight straight away. Okay, so yes, it is relatively new field when we apply the the scope of can we do it on a with a programming language or with a simple function call, but it isn't that relatively new field. And yes, for data science, it's more than these Python libraries or the programming skills. What actually make you a good data scientist is the domain knowledge. What you are doing, what data are you looking into, and why you are doing it. What is the insight that is more useful than the other? Okay, I shall tell you some example here. In World War II, there were flights used in the war, and when flights go into the battlefield and when they come back, there were only two particular places in the flight where lot of bullet wounds were there. So the engineers in the workshop, they thought they have to protect more where the bullet wounds are there so that the flights will be safer. In a way that makes sense, right? There are too many bullet wounds at two places, and if we put stronger plates, flight will be safe. But then some intelligent person said that all the flights that are returning have lot of bullet wounds at those two places. But flights that are hit at the other places are not returned at all. Probably we are supposed to make the other places stronger, not those two places. Right. So that's where data analysis and data science take two different paths. Data analysis, it looks at the data, tells what it is saying. Data science goes beyond, tells what is actually implied by it. Okay. So, well, this is not my story. This was the story that I was told when I started my data science journey by Microsoft professionals. Okay. So what is Python? Well, you must know this already. Python is high-level general purpose programming language. It's popular not only in analysis and data science, but because we are here in that particular discussion, that's why I kept that line. But it is popular with everything, not just those two. So if some of you are really enthusiastic about C++ or C, you have a very good argument that C or C++ is really fast. Yes, I did a comparison myself firsthand. The C program I wrote took about 14 seconds to finish, whereas Python program took more than 3 minutes. Okay, so there is a lot of difference between when you compare to those mid-level languages. But what is the difference? In C, your code needs to be compiled before, which is not the case with Python, which you know that the interpreter-based languages, compiler-based languages, all those different things. I'm not going deep into that. So anyway, so Python is very popular because of its ease of use and its high level, and you can do almost anything with it. Why? Because of the last point. It's open source and free to use. Free to use, so you can download it on any PC and you can start working on it. And the second part is more important, open source. You got an idea, you want to develop something new and you want to make it available for everyone. Build a new library. That's what the libraries I mentioned in the first slide. The NumPy, Pandas, Matplotlib, these are just like that. Someone got an idea, they thought we need a library that actually analyzes data faster, in better, and gives the functions fingertips. So let's build NumPy. Now we want a library that actually works on table style data with SQL style functions, that where clause, that select list, and group by, etc. and all. Okay, let's build Pandas. Visualization. You don't need to really worry about writing thousands of lines of code to get a simple graphic chart. Let's have a library for that. That's Matplotlib. Scikit is core data science concepts. All the algorithms of data science what we are about to discuss are in Scikit. Like this, there are so many hundreds of libraries and a new library coming every day. So you can build your own one new library as a project for one of your theses, or it is open source. That means there are no restrictions on what you can do, what you cannot do. Okay, so I'm going to go through some basics of Python, not all of them, that are useful only for our parts of this discussion, data science. Some of these are basic data types, booleans, numbers, strings, etc. But these are more important in data analysis and structure. Lists, tuples, sets, and dictionaries. We use most of them almost in every project that we deal with data. So what is list? List is basically an array-like object, not array-like object. In programming or in proper technical terms, it is very close to the linked list. But we can access the list items like array with array of 0 or array of 10 with the index, etc., the position, and we can do operations also based on the position. We can insert at a particular position, we can remove at a particular position, etc. Right. Tuple is again, it's immutable. First thing, you cannot reassign to the same way. I mean, you can reassign while you're writing the program, but in the background, it is actually discarding the old object completely, and it's creating a new object when you reassign the tuple with a new value. What is the difference between set and a tuple? Tuple can have duplicates, but set will never have duplicates. It's mutable against set. That means you can add, delete, those kind of operations you can do to the values. And reading a value from set at any position is order of 0. It's a constant time. Whereas in list, reading a value from different position changes the time. It's order of n. Okay. Dictionary, it's again mutable, but the difference is it's key value pairs. You have a key and then a value. Right. When you have syntax, both sets and dictionaries shown in curly braces. But when you initialize, if you want to initialize a set with empty value, you have to say set or as a function. But for dictionary, you can just open and close the braces. Okay, that's core data types that are mostly used while doing data analysis or data science projects. Right. So I'm going to show you some examples with NumPy and Pandas now. NumPy is like a multidimensional array, matrix-based system, whereas Pandas is a table-like data structure that I said. And yes, Pandas, as I said, it does all the DML operations that you can do with a SQL statement, just like you do on a table. So what is NumPy used for? The mathematical and statistical operations. Like if you want to calculate an average of a set of values, if there are 1000 values, all you need to do is call a simple function on that object with the 1000 values. You don't have to write a for loop and then do all the math we generally do. Okay. So I'm stopping the slides here. I'm going to go for some examples here. Fundamentals. So I have some data in a list. This is a list. See, when you assign with square brackets to a variable, this is a list. And before I start running that, to get to here, you need to install Python. You need to install Jupyter Notebooks, those two. So this is Visual Studio Code, this editor. If you are comfortable with this editor and you want to run this way, yes, this way we can do, or there is another way to do that. So, no, not this, sorry. This is to install Python on its own and then install any other library you want as you go, right? So I'm putting this link in the chat. Okay. So when I'm sure some session before me has covered this, but I'm just making sure if you missed or anything, you have that option. So the second part, Anaconda, what is this? It's a packaged tool to work with Python. So what is the difference? If you remember, I'm not sure. I'm giving some examples that were there when I studied in, when I did my engineering, etc. There was like a different C, ANSI C engines were there, and then there was another C engine was there. I forgot whatever it was. So we used to download one of them and install on the PC code in C, or again C++. In Linux, we can just say install GCC, but in Windows we have to download and install GNU or something like that. So like that, Anaconda is a package tool. If you download and install Anaconda, it gives you a Python-based environment where it is kind of containerized. You can install whatever the tools, whatever other libraries you want, and more like a Kubernetes container basically. All right. So right now we are using one of those Anaconda installations. So if I run this, so we need to have one kernel, and for me the kernel I have is that one, Anaconda Python, the one I installed. It is going to take a little long for the first cell. So here it is. So that's a list I assigned and I printed, nothing more. Right. So if I now import NumPy and the same data I'm taking here into another object and print, what is the difference? You see, they both look almost similar. Both are looking like list in the square brackets, but the difference is in the comma, and there is no comma. But that is not the actual difference. The difference is how they are stored in the background. So if we go to this Jupyter variables, you see the first one is list, whereas the second one is array. And the array has 22 rows. No, 22 values. Okay. And this is another variable viewer where it also gives you indexes. and the values and some histogram based on the values. Okay, let's go back here. This is not necessary. So there are some more functions where we can run on that NumPy. Grades.shape, it tells you what is the basically the columns and rows of that data structure we got data in. And mean, which I said a while ago, just gives you the average of the values. And now I'm taking another list and I'm taking that into one more NumPy array, and let's see a few more things on that. See, average, again, average study is the mean of student data, but this time I took two values. If I run the shape of this student data, you see now you got two columns with 22 rows each, right, like that. And here I'm introducing you to pandas. The basic data structure in pandas more or less is data frame. Very rarely we use others, but we use data frame almost every time we deal with pandas. Okay, hope that's not for me. Sure. So how do we access the data in data frames? Not using the index like this, but we have to use .log. So what is the .log? It is the row number basically. So log gives you the rows. So when you say log 0, it is the first row. Name is Dan. Study hours is 10. That we got it from here. And grade is 50, and that is from the first cell here. Right. So this is how we can define a data frame from existing data sets, different data sets that we already have. We can pass them and create a data frame. Right. So what if I want to have only one row out of this? Like I said, in SQL, what would you do? Select star from where some condition. And here I'm saying where name equal to Twinkle. So there it is. Now that row, that is Twinkle. And the 15.582.0 comes from that particular same row. So if you want to see the full data set, I'm not sure it would be possible to see the full, but we can see some data. No, let's see different one. Sorry. Yeah, it only gives 5 rows head. So this same thing we can use in a different way as well. This way, this is dot query where name equal to Twinkle again. Condition is given, and here we have to see. If you observed, that's the data frame first. Then again, data frame, the column which I'm selecting is equal to the value I want for. See, the same thing here, little bit written different, but exactly same operation. Query where name is the first column equal to the value, and now this is in two different quotes. Alright, first the entire condition has to be in quotes, and again the value has to be in quotes because that is a string. Right, and this is another way of doing it. The data frame has dot like member objects, object dot one of the variables in it within that. All right, so all three of them give you the same result. Now I'm going to introduce you to more little large data set. That data set can be downloaded from this link. I'm going to share you these notepads, notebooks later. Okay, so I downloaded already. It is here, data frames grades.csv. If you want to see the data, you can see here. There is name, study hours, grade, and that's the CSV comma separated values, right? So going back here, that's, see, I just read that data using pandas PD. If you remember, we imported pandas as PD here, right? it's one function that is read CSV. Pandas have so many other functions to read from Excel, read from JSON, read from XML, or there are so many. You can go through Pandas documentation. Pandas has about 60 or 70 different functions, right? And we don't use all of them every time. So this is just showing the data frame. Okay, it's showing in multiple sheets, multiple pages. So if you observe, the last two rows have some nulls. Okay, for this row has one null and this row has both nulls. So what we can do? So let's see, is null, and now if you see the last rows, it says true there. Okay, so that what would you do with it? Obviously nothing. It's just to see the data. These functions and these things to analyze the data. This is where the data analysis and the science, that the difference comes into picture. Before you go and do any data science operations, you first need to understand your data. To understand that, you have to analyze, you have to do so many other things, right? So if I did that sum, there is 1 study hour null, 2 grades null, 0 names null, right? And what if I want to change the nulls with something? So in study hours, when there is a null, I want to replace that with the average study hours of all the remaining values. So if I do that, now if I go here, study hours here. See, the null now gone and change it to 10.41, but grades is still missing. Now let's say I want to remove the values, anything from the entire data set, whichever has null. So that's the function for that. That's the function drop NA, and fill NA is when we want to replace the nulls with something, right? Now if we go and see, it will be 21 rows instead of 23. See that the 2 rows are gone now. Okay. Now to get mean and median on data frame itself, there are functions like this mean, which are data frame functions. So they are in Pandas and NumPy. So we just calculated into and stored in the variables, but we didn't print. That's why you don't see anything. But let's see how many students studied more than mean study hours. That's simple filter, and you would see only one sheet. So there are 10 rows. Out of 21 students, only 10 students studied more than the average study hours, right? And now for those students who studied more than the average, what is the average grade for them? That's 66.7. But what is the actual average grade? Let's print this. That's the overall average grade for all students, and this is the average grade for the students who studied over the average study hours. Okay. So let's say 60 is the pass mark in the grades. Okay. So we can add one more column to the data frame saying if they are who have either passed true or false based on their grade. So if we do that and we print the data frame, now you get extra column, data frame, true, false values, nothing else in there, right? Then group by that passed column and say how many students did. There it is. Okay. So if we want to do that, would we take it? So after the group by, if the first one, if you see, it gave all columns and it did the counts, but we want only the name counts. We don't want study hours and grades, okay, because they don't make sense to get counts of them. So then we can select what column we want. But what if we want to select 2 columns after that? Right. So first, those two columns we have to keep as a list, and that list has to be a parameter for the data frame. So it is a double indentation. I mean, double braces basically. It is goofy syntax, but that is necessary. Okay. There it is. And we are not getting count this time. We are getting mean. So for the students which have failed, study hours, average study hours is 8.7 and average grade is 38. But for the students who passed, the study hours, average study is 14 and grade is 73. Right. So sort values, yes, we can do some other operations on the data frame like order by. Basically, that's what sort values does, right? And we ordered by grade, so that's why the last grade was highest and the first grade was the least, 3, right? And here again, this time we are ordering by descending. So ascending equal to false will make it descending. Default ascending is true. So if we do that, see the highest study hours is at the top, right? So this is like a 101 of NumPy and Pandas. This is nowhere near to comprehensive session. It is kind of introducing you to those libraries. There are hundreds of more functions in both of them. You can go through the documentation, and the most important and the best way to learn anything is just practicing. Type, if you want to like try the same command, don't copy paste, just to type it again. That will make your life more better and you will learn more. All right. So let's go back to this. So data types, okay, data science concepts. Before we go to the further two libraries that what I said, Matplotlib and Scikit, let's first see what are the data science concepts before we go there. So there is like, where do we use data science and what are the types of it there? Okay, that we see here. Data science is used in so many different types of problem solving. So let's say regression. So what is regression? Regression is basically when you have a lot of inputs and your output is a numeric value which is continuous, right? Continuous can be like real numbers or just integers, but it is a numeric continuous value, right? For example, given the study hours we just said and how many classes attended and the student's age, can you guess what would be the student's grade at the end of the exam, right? Or given the location and distance to the nearest amenities and probably the size, the number of bedrooms, number of rooms, and the garden size available, can you guess the house price? And these are all like regression kind of metrics. Then what is clustering? Clustering is you are given a set of data. Looking at the data, you say this bunch looks together and this bunch looks different. Like you divide it into like 5 different sets, right? And say these are 5 different clusters in this data. For example, let's say in your college you have entire college members in one area. Then you look at from a top angle and say, okay, that group looks only the lecturers we have, and this group looks the computer science students, this group looks the mechanical students, and this group is our non-teaching staff, right? So like that is clustering. Then what is classification? Clustering and classification are almost similar, but not quite. So classification is you give the data, you already know what are the classifications you have to get. So for example, you give 10 some thousands of images and you ask classify them between dog and cat, right? So you are telling the output as well, so it just has to classify, right? So in clustering we don't tell how many clusters or what clusters it has to come up with. It just looks at the data by doing different operations. It comes up with the result saying this data can be clustered into 5 groups. But in classification, we tell the problem statement itself. We give the parameter how many classifications we want and what are the classifications as well. Right. Feature selection and text mining are not outputs of data science. They are the concepts of data science. While we are doing any of these three problems, solutions are these, we do these two, feature selection and text mining. So what is feature selection? For example, let's say on a sunny day, there is a cycle shop, okay, who rents out the bikes for anyone that comes. On a sunny day, when there is no wind, a person comes up and hires a bike. So it's more or less more likely that on a good weather day, a lot of people come and hire the bikes. On a bad weather, windy day, rainy day, less people hire the bikes. Okay, and sometimes no people hire the bikes. But let's say while capturing that data, we captured one more information. The information is, what is the person wearing? The person who came to hire the bike, what is he wearing? A t-shirt, a jacket, or winter boots, or slippers. So when we look at the data, on a sunny day, it is most likely the person is wearing slippers and a t-shirt. On a rainy day, he's wearing a raincoat, and on a winter chilly day, he's wearing a winter jacket. But if we look at the data and analyze based on what the person is wearing and whether the bike is hired, there may be a strong relation, because based on the temperature, the person's dress sense changes, and based on the temperature, the bike hiring also changes. Right. Okay, so but the dress and the bike hiring are not strongly related. The dress is also related on the temperature, not on but the dress may give you similar result as the temperature for hiring, but it is not related. So we have to make sure which one of these two is actual feature and which one is not. Right, that's what feature selection comes into picture. At the end of the session, if there is time, I'm going to talk you through one of the real-time examples which we spent 1.5 years to come to a conclusion. Okay, so there you will understand more. Yeah. So association analysis is again another data science problem. That's one of the algorithms. Anomaly detection is one of the data science problem. Anomaly detection is one of the things that we use almost every day. That is, sorry for this, I came here because there is a lot of requests for link about this code I'm running. So if this is a public project on GitHub. If you go to that link and download this entire folder, I'm currently went through this. I am going to go through all of this except the last one, the 7. Number 7 is for you to go through yourself and understand. Okay. So anomaly detection is one of the fraud detections that happen. For example, we pay by credit card and we lost our credit card, or someone stole our credit card. They go and pay a bill for about 1 lakh rupees, like that. Then in your general credit card usage, you never spent more than 2,000 rupees. If that is the case, anomaly detection spots it immediately and blocks that transaction straight away. But how is that happening? There is a trained model behind the scenes which kept in production. I will tell you that as well, what is training and how do you keep it in production, etc. So there is a trained model that kept in production and almost monitoring every transaction that's happening, right? And the minute it decides the transaction is anomaly, it blocks it. And sometimes it blocks your genuine transactions as well. If your credit card is just the same example, your credit card you are using, but every day the maximum amount you do a transaction is 3,000, but suddenly one day you decide to buy something which is more than 1 lakh. So the transaction will be blocked. You will get a call, you will answer, right? You will have to go through some security questions from the by the bank. Then only they will unblock your card and you can answer. You can do the same transaction again. So these kind of things, recommendation engines, deep learning, time series forecasting. For example, it is what stock markets. For example, will the stock market go up or down for given a time? So the stock market, if you analyze and it given some parameters, will it go up or down? For example, Apple, when a iPhone is released, its stocks go up, right? Because when the iPhone is released, people queue from 2 days before to buy it, and suddenly there will be a high spike, right? But over 2 3 months, it gradually goes down. Then there are two perceptions. Who is looking at the data? If Apple is looking at it, when it's going down, they do some kind of, um, they take some action so that the down doesn't go too much low. So they kind of release one more product, like maybe iPad, or they announce something saying we are giving AI onto the what MacBooks, or we are giving even onto the phone that we released last month. We are giving some new tool onto it, like that, right? So that the downward trend stops and flattens out, like that. But what if a customer is looking at? So from outsider point of view, you want to buy the same phone, but not on the day one because it's on the high spike. So when it's going down, you buy one version before because the price goes down, obviously. Right. So that kind of, it depends who is looking at it. Based on that, the KPIs changes. Right. Deep learning and recommendation engines, and these are some things. Time series, deep learning, recommendation engines, and even anomaly detection to an extent are not easy to work out through with pen and paper, no matter how much time you get. But for the top three, or even association analysis, there is a chance. Maybe if you given a pen and paper and you have a strong IQ, for small problems it may take like 20 to 30 minutes. But there will be the times where you might need 2 3 weeks to solve that problem. But there is a chance you can solve it. But from these ones, no, you need a computer that is not even the home CPU based computers. You need GPU based computers, right? So this is again not complete list. As I say, this is not a comprehensive list. This is a 101 kind of introducing to you to the things. So there are some different tasks, not all of all of them here, a few of them from there, and then the description and different algorithms that are used for all of them. So some mostly used, the popular ones are like this one, support vector machine, that's used these days, very highly used. Random forest and gradient boosting for regression is one of the best ones that generally gives good results, right? And logistic regression is not really regression model, it's a classification model, sorry for that, right? So anomaly detection, there are some algorithms for that, sorry again, right? There are multiple algorithms, and that list is not full. There are hundreds more algorithms that are available. And so from there, I would say, okay, so that's types of data science. That's the first one. So what are the other parts? So data cleansing. Once we get data, like we did already, there were nulls in the data and we removed them. and sometimes data is wrong. For example, we have a field, or we are collecting data, and one of the column is what is the gender, and male and female. And while filling, there could be data entry issues. Someone entered, when there is male, they entered something like, instead of M, let's say they entered nail, N-A-L-E. Computer immediately doesn't understand it because it is expecting only two values, male or female, right? And these days, again, there is a trans. And so that in that sense, we have to set extra one more value into the valid data set. So like that, this is all data cleansing comes into picture, and numerical values where we expect, if there is alpha values, alpha numerics, that is wrong, and when we expect only some classification of values and suddenly we get something outside of it, that is wrong, etc. All right. Basically, we need a clean data set, right? Then explanatory data analysis. This is kind of skill based, I would say, because the more you look into the data, this is where the first point I mentioned, data science needs domain knowledge as well, right? So if a banking domain person is looking at some data, they look at the data in a particular way, and if a healthcare person is looking at the data, they look at it in a different way, right? So based on what you are looking for, you look for particular features and what is their values and how the data making sense, what is its mean, what is the standard deviation, or what are the classification of values, etc. So you first understand the data before you decide an algorithm and you do the actual data science operations. So establishing the purpose. So once you understand your original data, that's when you set up a purpose. Okay, you are given some, let's say, laboratory report, healthcare laboratory report of blood tests, right? Samples. Age, blood group, and some other red blood counts, white blood cell counts, and I don't know, there may be so many other metrics you would be looking at, and then decide whether that person can get what diabetes in future, right? So that's your purpose. Once you looked at the data, you are looking at what can you do with it, right? Then decide this algorithm, because here we are classifying, only two outcomes are there. Can he get diabetes or not, right? Can he or she, that person, can they get diabetes or not? Only two outcomes. So you have to decide an algorithm that is classification algorithm that works very well. But if you are looking at like the example I gave before, like you are looking at a house price prediction, then you have to take an algorithm that is regression based, right? Then outcome. What is your final model that you got, whether it is giving you the right results, and of course, this is another thing. Data science will never give you 100% accurate results. There is a accuracy score or there is a confidence score. So when you say, even for that healthcare example, this person may get diabetes with 90% accuracy, right? So out of the 100 predictions you make, 90% are correct, 90 predictions are correct, with a confidence level of 60%. I am only saying this person may get diabetes with 90% of chance, with my confidence of 60%. The model confidence is 60%. Okay, like that. So that's your outcome. So that's basically the concepts of data science. Now let's go through some of the other examples using scikit-learn and matplotlib. Matplotlib is for the visual representation of the data. When you look at data in Excel sheets or tabular formats, you may stare at the data for hours. There is a chance, if the entire data is fitting on your screen, you can even make the relationships clear and you can understand the data analyze very well. But if it is more than like thousands and thousands of rows, looking at the data itself may not give you the proper insights, but if you will look at that in a pictorial representation, right, where an image speaks 1,000 words, it will make a lot of sense for us. The scikit-learn is what the algorithms that we use in data science that are already pre-built, right? All we need to do is make a function call, right? So these 4 libraries and the things that I'm about to show you with code, these are all you can work on any computer. But what if you have a problem that needs a supercomputer, or what if the algorithm itself is going to run for 2-3 weeks? How can you do that? So that is where the AWS and Azure, GCP, those things comes into picture, right? They provide you the compute engine or the computer, right, the CPU, where you can call a Python function from your PC, which runs on the cloud PC, and it runs for as long as it needs, then gives the results back to you. So your PC is running it, waiting for the results, but not using your PC CPU, right? Because we need strong, powerful computers there. So for that, these 4 libraries are not enough. We need to install more libraries, which are basically depends on which CPU you are using. For example, if you want Azure CPU, you need to have Azure SDK installed, and AWS CPU, you need to have AWS SDK installed, and the login credentials you have to provide before making the call, like that, right? So let's go back to here. Let's see some visualizations now. So the same data now, I'm taking the same grades file, this file, doing the first few operations that we did, that is adding the passed column, right? And we are removing the n nulls. So that's the first operation I'm making. So that's data, right? We'll have 21 rows, I believe. Yeah. So now this is our first plot. From matplotlib, we are importing pyplot. As PLT is just for our ease of coding, but we need to import pyplot. That is the one that is useful to draw any diagrams. Okay, so this first chart we are doing just a bar chart, right? On the x-axis we have names, on the y-axis we have grade, right? This is important. All this, anything you do, you have to put the settings first, but at the end you have to call this show. Without showing, we won't see the image. So here is it, and as you can see, it's not readable here, and it's not looking so good. So let's make few more changes onto this. So I stopped that, I uncomment this, and now changing the title to student names, x label name, y label grade, and this is the part that is important, x takes. So if I do that, you see now it changed and the names are readable, and there is a student grades at the top, and it says grades and it's the names, giving more information, right? And the first part, if we do this figure size, the size of the, okay, the PLT represents everything on the white panel, but except the white panel itself. When we say fig, that represents the white panel as well. So now the white panel is increased. That size there is pixel size, but if you, that 12.8, 7.2 represents, times it with 100, 1280 and 720. So that is the pixel size we are looking for. DPI by default is 100 dots per inch, I think. Yeah, right. So the 12.8 by 7.2 represents 1280 by 720. So now we are going to draw a few more diagrams here. This is again plot dot subplots. We are taking 1, 2. So the 1, 2 means one row with two columns. That means we are going to plot two diagrams, not one. Okay, in one row in horizontal. And fixed size is 10, 4 means 1000 by 400. Right, when we do that, we cannot use plt dot anymore. Right, so this function subplot gives a tuple as a result. The tuple is first figure, then the axis. So the axis 0 is the first one because there are two axes here, one row and two columns. So there are two values in axis, axis 0 and axis 1. So in 0, we are going to put a bar chart, same thing, names and grades, right? And in 1, we are going to put a pie chart for the pass count. And the pass count is calculated here. We don't have pass count so far. We only have the values passed, whether true or false. Right. Let's run this. You see now the same image. This image is here on the left side, and the pie chart is on the right side. Right. Passing grades. And we can do like more. Right. This instead of the grade, what did I change here? Color, nothing much. No. Why I wrote this cell now I remember. So here I downloaded a plot. We imported plot from here and we set all the different parameters and ran. But the plot itself is a method on the df students. We can do that. So df students dot plot dot bar, right, the type of chart, and then provide some parameters. There it is, right, like that. So yeah, that's all. Just wanted to introduce to the visualizations using matplotlib. That's the most important part, right? Now let's see some more distribution methods using matplotlib again. Again the same data set I'm getting, and I did all the first operations, so we will have 21 rows here. Yeah, this time doing some calculations. We want to get what is the minimum, what is the max, what is the mean, average, median, mode. I hope you know what mean, median and mode means. Mean is the average, like arithmetic mean of the entire values, whereas median is the value that is at the middle of the values. When you order them in a row in particular order, whatever is at the center, if there are two values at the center, take the average of those again. That's median. Mode is the value that occurred the most number of times. So mode will give us a list of values, not one value, because there is a chance in a given list of values there are multiple values with the same number of occurrences, and they are the highest occurrences, right? So that's why we must use which value we want. 0 obviously gives us the first value and safest value, because what if there are no multiple values, only one value is the mode, and because it gives us the list, we can take off 0 with full confidence, it won't fail. Then we are again doing a histogram of those values. So, and here you see this histogram, we are trying to do the grades, but then all these values we got here, we are trying to draw some lines for them and with different colors, right? So let me run this. Now you see that's a histogram. This is the min line on the left and this is the max line, right? But mean, mode and median, they are all together almost in the one on the other at the center. This generally suggests when mean, median and mode are together, the data is more or less evenly distributed. It is a normal distribution, right? And if they are scattered, mean goes this side and mode goes this side, like that, we get data either right skewed or left skewed, right? This insights like understanding the data that we have right skewed or left skewed, that gives us a confidence and that helps us to decide what to do with the features. Are there outliers? Should we get rid of them? Or if there are no outliers, is the data correct? Then which algorithm to choose, etc. Those kind of things, it will help us. So this is why we first analyze the data using pictures, and when we look at them, we make some decisions, right? So this is again. This is called box plot. So what is a box plot means? Box plot draws a line that from least to the highest and a box in the middle. So the middle box represents 50% of data. Okay. And the top and bottom are 25% each again. All right. So now, right. So if we compare this histogram and this box plot together, slightly not possible because this is horizontal and this is suddenly vertical. So what we can do, we can change the box plot let's say false. Yeah, now you see you get the same distribution as that. So usually we look at both together in one plot so that we know what to do with it. Well, I actually have that here. Yeah, I combined both of them here, and then if we run with vert equal to false, see, now we see the data, and as you can see, it's evenly distributed, and the middle 50% is between somewhere close to 40 to just over 60 there in the middle, and remaining grades are 25% on this side, 25% on this side, and they are actually equal size almost. So that tells us this data is properly even distributed. All right. So this is the density, or the other term for this is called bell curve, right? And when bell curve is again almost symmetrical, that data is the same thing, good distribution, and we can use that. So let's do some more data science concepts on this, on the same data set. So this is the same function that we just wrote before, show distribution, right? There it is, the same diagram that comes. So if we want to, this is all on grades. Okay, so what if we want to run the show distribution on study hours? That's why we created a function here rather than doing this just on grade. Okay, we are passing data var data. So and the call here was grade, and now I'm going to call with study hours, right? So now you can see the data is different, not evenly distributed as grades. Even though the grades were even distributed, the study hours shows there is one very low, just 2 hours or something, and that's here. So it's not even 2, it's 1. The minimum is 1. So 0 here. No, so that's one data point. This is what box plot clearly tells us is it left that one data point out and gave you this distribution. That's a straightforward indication that this is an outlier. That's not falling into place when they tried to do the data distribution. All right. So the remaining all study hours are from 5 to 16. So when we want to do some kind of analysis or data science, this is where the data cleansing or explanatory data analysis comes into picture. Because we are sure this is an outlier, we kind of remove it from the data and then do the remaining data analysis. Right. So here is, see, now I'm removing that data and doing the distribution again. Now that's done. You see the min went back to the box plot, and the min in the distribution, both are histogram or matching. Right, this is density, the same bell curve thing, and I'm going to show it on this this is on grades, right? Call me, no, study hours after cleaning. So now you see the mean, median, and mode, they are not together, they changed, right? Median is in the middle, mean is on the left, and mode is on the right. So the data is now a bit skewed, right? We have a long tail, which means the data is right skewed. So then this is okay. This is where we do the data science concepts. What we generally want to is, what if we put the points, study hours on x-axis, and let's say grade on y-axis, and we try to come up with a distribution line on that. Okay, before we go there, yeah, I think you know what variance and standard deviation means, right? Variance, well, let's talk with standard deviation first. Standard deviation is the amount of movement from the mean on either side, right? But for what? That movement for what? So 67% of data, 68 or 67, 68, that's the magic number. So 68% of data is falling between mean minus standard deviation and mean plus standard deviation. So let me, okay. Come on. Sorry, something is wrong with it. I never use it that much. Sorry, I'm not too good with this, it seems. Anyway, so from mean, the standard deviation when we calculate that 3.4, so from mean value is 10, 10 minus 3.4, which is 6.6, and 10 plus 3.4, which is 13.4. So from 6.6 to 13.4, in that range, 68% of the total data will be there. That is what standard deviation means. But how do we calculate it? It's simple. Take for each value on that line, and take the difference from mean, square it, add it. That's variance. No, that's first take the difference of each point from mean, square it, add it, then take the average of it. Basically, that's what variance is, and square root of it will gives back standard deviation. But why did we square and why did we do the average? Well, we can just do this negative, some values are negative, some values are positive, and they will give us 0. So to avoid that negativity, we square it, then take the average, that's variance, and square root of variance is standard deviation. So this is a calculation we can do manually. This is what I meant in the beginning. For classification and regression, if it is necessary, we can work out with pen and paper on how to do things. So we will need standard deviation when we are doing some distributions. But Python and pandas, they all give us more readily available metrics for this. So if we just run this df students.describe on the data frame, Without doing all this, we will get that values. You see here, what happens? See, that standard deviation we already got, and that standard deviation of grades, and minimum is that, maximum is that. That is like the min to max is called the range of the data set, right? And what is this 25%, 50%, and 75%? So the value 9 on the list, if we order from 1 to 16, the value 9 is after 25% of data points. But value 10 is after 50% of data points, right? So that means 25% of data is between 9 to 10, right? But then value 75, the next 25% took again 2.337. So 12.375 is at 75% of, after 75% of data points. But from 75 to max 100, it took again a little longer, right? So that's why this skewness comes. But between 9 and 10, we have 25% of data points. Like this, we have already the readily available, that metrics that we generally need to understand the data, that is at our fingertips with a single function call, right? So again, this DF sample where we are taking the outliers out, and this is the DF sample, and we are doing a box plot here just to see. And now this is box plot based on passed and failed, right? A columns is study hours by passed. So the number of study hours, when they are low, they are failed, and when they are high, they pass. That's quite obvious, right? If we study more, we get good grades and we pass. That's generally the scenario. So this time we are doing a bar chart together with grades and study hour. So looking at this, do we get any kind of relation between those two? Not quite. Why? Because grades can range between 0 to 100, whereas study hours range from 0 to 24. At max 24 hours are there, right? So how do we normalize this? That is the word. We want to normalize the data, right? Bring both of them into the same scale. Then do the bar chart and see what is the relation, if we can establish any relation between those two. So how do we do that? We need something called scalars, right? We want to adjust the scale of both data sets, both grades and study hours. So there are multiple scalars available, and this is the first time we are using sklearn, right? The scikit-learn. Even though the library is called scikit-learn, when we are calling in Python, the S itself stands for SCI, K for kit, and then learn, right? Scikit-learn, pre-processing, clearly that term itself is self-explanatory. Pre-processing, before we do any data science algorithms or any data science concept, we apply any kind of data science functions, we are trying to do pre-processing. That is called feature engineering in other terms. Right, we want to do something, so we are importing a min-max scalar, and using that scalar we are fit transforming both grade and study hours, right? So now if we do this and do the same again, bar chart, right, and fig size same 85, see, this time it tells us the grade and study hours are strongly correlated, right? Sometimes even though you study more, you got less grade, and sometimes it's equal, but more or less there is a strong relation between those two, right? So now, so what is that relation called? It's called correlation. The correlation value, again with Python, we can get it with a single function call, and there it is, 0.91 or 91%. There is a 91% correlation between study hours and grades, right? So now let's do instead of this bar chart, let's do that scatter plot, which is basically drawing points on the x and y axis. So x-axis is study hours, y-axis is grades, and you can clearly see as the study hours grow, grades also grow, All right, it's a single line. So if we want to do a regression model on these points, let's say linear regression, that means we want to draw a straight line on this, right? So what is the straight line equation? The straight line equation usually is y equal to mx plus b, or in other words, ax plus by is equal to c, right? But if we write in this format, y equal to mx plus b, m is the slope and b is the intercept. That's why this form is called slope intercept form, right? So y equal to mx plus b is the slope intercept form of this data. But the line we are going to draw will not be y. Let's say it's y dash or f of fx, right? So that is the regression line. That's okay. So now if the regression line, let me do something here. Because I'm not good with whiteboard, I'm taking a paintbrush. Sorry for that. So if you draw a line like that, and we got that, so this is f of x and the actual point is y. So if this is for this x and this is y and this is f of x and that is y, the difference between these 2 points is error, right? So that is error is y minus f of x. So again, like we calculated the variance, because if we have another point here and another point, 1 point there, 1 point here for this x, the error will be 0 if we just add them. So we want to square them, then add them, and then take average, then square root, which is basically called root mean square error, which is a metric that is useful for almost all regression models, which tells how accurate that model is, right? So to calculate this fx, there is this SciPy library, and from there we can get stats, use a linear regression, and we can get that m and b values out using that, and then we can draw the diagram. See, so that's the line now with linear regression, and if we just plot that, right? Now, and if we print the m and b, these are the values. And now if we are given a new value, new x, any x, let's say, and we want to get the value on this line, right? All we need to return is m star x plus b, right? So that is our final model, right? Once we get m and b, this is the model we say. So any new x, we are going to get this m star x plus b. So now let's see, predict the values. Predict 18 hours. If we study 18 hours, what would be our grade? 95. And now if we study 22 hours, what would be our grade? 120. And this is where we need to put more controls on our models that we generate. You cannot get 120 grade no matter how much you study. The best grade you can get is 100. Right. So this is also like one of the features we put in data science, where gateways, the controls, right? How much you can guess up to. You can't go beyond 100 on this particular one. So this concept, like you first create a model and then predict the values for the new values that are not there in the original data set. That's what the concept of data science wholly is. You take a data set, you train a model, then you take values that are not in the trained, or sometimes in the values in the trained as well, pass that as the parameters, and you get values. That's what you are looking for. What can happen on these parameters, given that these are the parameters and this is the already what happened values, right? So that's the entire concept of data science. Now let's go through one example where we can do what all these things, like the model identification and predicting, first training the model, then predicting, using only Python based models. Not, we are not doing anything here. We said use the linear regression and get m and b, and we said we wanted to use m and b and then return this m star x plus b. We don't know what the equation behind as well. We just want to pass the values, train the model, then pass the values, ask the model what happens, right? So that is where this scikit-learn comes into picture. That, okay. So this time I'm not taking the data set that we had, this grades data set. I'm taking from scikit-learn. It provides some few inbuilt data sets. I'm taking a house price data set from there, right, in California. I didn't print the full data set. I only printed feature names. What is the column headers of that data? Okay. Medium income, houses, average number of rooms, average bedrooms, population, average occupation, latitude and longitude. We have 8 features in there. Okay. So now, where is the price in here? It's not there. This is housing.data, and housing.target is the final price. Okay. And if we print that, so these are the 8 features, all those values, and then the y of 0 for that house, the price is 452,000, right? Okay. So that's the first row. Basically, we are taking by 0, right? Index 0. So there is this thing called train test split. What is that means? Given the data, we want to train the model. But before we give the model to someone else for predictions, we first want to test the model as well. So when we get the data, we first split into 2 parts: train data set, test data set. We can do that manually, but not for millions or thousands of records, right? So what we do is we just tell how much percentage of data we want to keep for testing and how much percentage of data we want to use for training. So train test split is a inbuilt function in scikit-learn, and we give the original data set. That's the input parameters, that's the output values. Test size 0.2 means 20%. This random state, this doesn't affect the split or anything, but the random state, if you call this train test split on the same data set with same test size without the random data set 2 times, the split will be different. First time, let's say first 800 records are taken as the test data set and the last 200 records are taken as the train data set. Other way, first 800 as train and the last 200 as test data set. But if we run the second time, it may take first 400 as, and from 600 to 1000 as the test data set and 400 to 600 as the train data set. So how do we say we want to run any number of times, but we want the split exactly the same? We want that data set as the test data set and the remaining 200 as the train data set, and that should never change. That's when we provide this variable random state and any integer that you think of, your favorite number maybe, right? Put an integer there, and no matter how many times you run it, you will get exactly the same data set out, right? It splits into the data set and it returns tuple of 4 data sets. First x test, x train and x test, y train and y test, right? Then take a model, train the data set. Just to train the model, all you need to call is a function called fit. That method is there in every model which we will take. So call the fit method of a model on the train data set. Then call the predict for the test on the test data set. Then compare the test data set, the prediction data set, the result, versus the test data set, the original values. then we get the score, R2 score. Because this is a regression model, we get R2 score. If it is a classification model, we get accuracy score, like that. Okay. So again, the linear regression model, where do we get it? As I said, scikit-learn has all the models that are inbuilt in here. So we are taking a linear model, linear regression, and from the metrics we want R2 score, because again, as I said, this is a regression model. We want to test R2 score. There are other metrics for regression models as well. One of them which I mentioned, that root mean square error. Right. So the R2 score for this model is 58.8 or 0.58. Okay. Can we improve it? Okay. We can improve it. There is something called feature engineering we can do. Right. So let's say we want to do some more feature engineering. So all we need to do is get a polynomial features or some other features in that pre-processing module from scikit-learn. Again, call this method fit transform. That is there again in any feature engineering or in scalars as well. Right. Anything that is in the pre-processing. So if we run that, see, it had 20,000 rows and 8 columns, but now it has same number of rows but 45 columns. So how did the data increase? How did the other columns get added? So for almost, when we do the feature engineering, what we do generally is we square the numbers so that if there are negative values, we don't want to, neutralize the positive and negative values and get zeros. So we square the numbers, we cube the numbers, and we do cross multiplication of the numbers, things like that. We do so many things, but we are not doing manually any of them. They are all done through this object, and it now increases it to 45 features. And I am going to run the same cell here again, right? There is nothing changed, same code as you can see. But this time, the data changed, the accuracy changed to 66 because we did some feature engineering here. Right. Remember this line, the same line that was there here, but it is after the feature engineering. If we don't have this line, we would get the same 58 again, because even though we did the feature engineering, we didn't change our train and test data set. Right. So what if we changed the models? We only tested on linear regression model. And let's see, there are two more regression models I'm going to take. That's gradient boost and random forest regression. Right. So this time I'm running these lines, but on all three models. So I used a for loop and for all three of those models, and I'm running the fit on that models. Right. So this is going to take a little longer because these models need more time. They need more computation power. Okay, this is a very simple example with 20,000 rows, and it's already taking long. So in real time, these kind of models, they go for like weeks. Sorry, sir. How much time do I have left?
Sir, you can continue for 10 to 15 minutes, sir.
Okay, thank you. Sorry if I am taking your time or if I am making you sleepy.
No, sir.
Not you alone, everyone else, right?
Yes.
Yeah. It's dinner time as well. So you can see it's running. It takes almost 2 minutes. Right. Anyway, let it run. So what we can do when we are doing that, and what we can do to improve it. So this is the same code from that cell. All the difference you find is this, right? N jobs equal to -1. What is N jobs? That is one of the parameters to this, and I am not going to change more parameters on this model, but only this parameter. When I say -1, use all the CPUs that are available, all the cores that are available on this system. Okay, when I did not say anything, it selects based on its own mind Or if I say n jobs equal to, let's say 5, it can use at max 5 cores from my CPU. But when I say -1, use all available cores. That would be the fastest way, right? So let it run. It may take 2 minutes or so. Then we will run this and you would see it would improve a lot, not little. Okay, 2 minutes 7 seconds, right? And out of the 3 models, you see that the random forest is winning 79%, right? Auto score says. So let's run again. This time we had this extra parameter. What happened? Okay, it's still running. So already first 2 models are done. Linear regression is done, and histogram gradient is also done. But it's improved because it's running second time. Probably it has more knowledge. But look at the time. In 19 seconds, the random forest also finished, and it gave me almost exactly the same auto score. Okay, and this is something you can see here, the second one, hist gradient boost regressor. Here we got 0.77 as the auto score, but here we got 0.82. Now that is winning. We didn't change any parameter, but how did that happen? Right, this is what happens with data science. The more you run, the number of iterations you do, the values change, the accuracy gets better. Not always, but you have to do few iterations to get it better, and then at one point it will go back, and that's what I'm going to show you now. Let's first do uncomment that. So I'm going to run, because that we got the best score, this hist gradient boost regression. So I'm using that, but this time, sorry, I'm passing a parameter to that model with max iterations of different values, okay, and running it. So as you would see, first with 100 it was 82.3, then 82.8 increased, 83.1 it is increased again, but at 300 it went down, and at 350 it again went up. So this kind of like changing the parameters and running the model, and which doesn't have any connection with the actual data set, excuse me, which doesn't have any connection to the actual data set, but we are changing some parameters. These parameters are called hyperparameters, and changing the values, and this process of changing the values, running again and finding which one runs best, that is called hyperparameter tuning, right? And now let's see one more parameter as well. That's the linear regression, that's the learning rate. Okay, different models have different hyperparameters, so that we have to choose based on the model we select. We have to pass the corresponding hyperparameters. So now we are running for 3 different learning rates and 5 different values, and it's checking which combination gives us the best values. So before 250 gave us the best, but this time 350.1 is already better than 250. And look at this, when we did the learning rate 0.001, the values went pretty low. So that's kind of too bad, that parameter. So when we observe that, we don't go below some values that we have, right? So what is the best that we got now? 350 on 0.1. Okay, so that is what we say. Out of these 3 models, we got a hist gradient as the best model, and in that model we got this parameters combination as the best, and that is when we decide, okay, let's save the model that's trained with these parameters, right? So to save a model that is already trained, if you are using just Python, we need a library called joblib, and we have to call the model. We have to save that model, the trained model there. So model equal to hist gradient boost algorithm, and then these two parameters are necessary, and they are 350 and 0.1 we said, right? That's the one. And model.fit, we train the model and save that model now after the training into one file, any file. And so let me delete this file because it's there already. And now let me run this again. Now see, the model is there. So anytime in future we want to predict something, just load the model again from the joblib. So if this is the only cell in this notebook, I need to have this command even here as well. What happened? Right. So just import joblib, load the model that was already saved, and run your prediction on that. Right. This is the prediction score. Now we got R2 score for the model. But this is when we got the data, right? Void test. But what if we want to get the output completely, right? So what we need to do is take this. No, not here. Sorry. Next test of 0. So this is now one row of data set. This is what we generally use the final model for. We find a new data point, we pass it, whatever the result that comes, that's what we take. What happened? Okay, it's the full data set we need to give. So let me change something. Okay, sorry. But this is the full data set, right? But what we generally do after this is we call this model with our new data points, and this time we are not checking its score or anything. What is the prediction? We want to use the predicted value, right? Like that. That is the price of the price of the house for that parameters. Let's see now. Yeah, for these parameters, that's the price of the house, and that is what we say. Like if we want to put our house into sale, we first run this model. I mean, call this predict for our house with the parameters. And whatever the value that comes out, if we are happy, okay, I'm happy with this price, so I want to sell my house at 330,000. Right. That's how we do data science with Python, without we doing any calculations, no standard deviation calculation, no variance, no mean, no histogram, nothing. Right. We just used the algorithms that are provided by Python in scikit-learn and then ran it. Right. There is another example here. If we have time, we can go through, or I will leave that also for you to go through. But on here, I'm going to tell you a few pointers. There is one website called this kaggle.com. I'm not sure how many of you know already, right? But if you go there, and if you look for data sets and sample data sets, there are thousands and thousands of data science projects on here, right? There are also kinds of projects, but there are thousands of data science projects, and you can see there are few searches I made. That is what this PyCrental model is, right? Sometimes they do computations, and sometimes you can just take data and solution also from there and do your own analysis. So this is where you will get better at doing data science and you can improve. Of course, you are all lecturers and research scholars, so it is not for you. But what I'm trying to tell here is encourage students to register on this on this website and take some project and ask them to solve on their own, or at least go through the solution that is already provided. That way, how they can improve. Okay. So again, do I have time to walk through this sheet, or shall we conclude here? Okay,
You can continue.
I can continue. Sure then. So this is another one of the data sets I took from the same website I just showed, kaggle.com, and this time we are going through this data set. The data set here is, we all know the famous ship incident of Titanic, right? Titanic went down in Atlantic Sea and a lot of people died. And this is the data of the people that were on board on that ship and whether they died or they lived. Now what we are going to do in this model is, given some parameters, and train the model to predict whether a person can survive or not, right? And finally calculate some scores and see which model does best, etc. Right. So this first one we need to import these two, so that's why we are running it. And this is pure Python coding for operating system objects. This is basically showing us all the CSV files within the data folder. Okay, so out of them we are loading only the trained data set, and that's the head of the data set that we saw, right? Then these are, if you remember in my first fundamentals sheet, as said, we can read about the data frame using some Python functions. So the info gives us what are all the columns, how many nulls are there, how many non-nulls are there, right? What is its data type, etc. And this is what gives us what is the standard deviation, what is the 25% mark, what is 50% mark, 75%, and min, max, right? For every numerical column, right? So by looking at this data, we can say like this passenger class, and this is another important point here. Passenger class is a numerical column, passenger ID is a numerical column, but neither of them, no, passenger ID never has a say on the outcome of their survival factor, right? But passenger class has a say on the survival factor, right? Survived or not. For example, you see here, passenger class 3 survived almost all of them. No, that's wrong. It's not related. Passenger class 3, it's the way they saved people is like they first set the higher class people, women and children, and then the women and children of other classes, then the higher class people, in that order they sent them on the lifeboats. So a male person, young 20-30 years age, in the lowest class has the lowest survival chance, right? That's why passenger class has a say on the survived, but passenger ID definitely doesn't have a say on the survived. And the fare, the higher the fare they paid means they are in the higher class or with higher facilities, so they survived as well. So those kind of things that we'll see, but this, by looking at this data itself, we can say something about the data, right? So that's why this describe function is mostly useful. And is null and sum, how many nulls are there? And this is surprisingly, there are 177 nulls in the A's, right? And these are just some other counts, value counts in survived. There are 549 not survived and 342 survived. And And this time we are normalizing. So if we make it to 100%, what would it happen? 61% survived, 38% did not. This is where we show again some diagrams that we did, but look at this. Why the age between that 29 or something like that is so many people are there? It's not really the case. The case that happened because of this line here, right? In is, I said fill an A if it is null, and we saw that there are 177 nulls, right? Because there are nulls, if there is null, fill an A with the median. So the median age is 29, and I used that for all the nulls as well, right? That's why that line is so high, but otherwise that's the distribution, right? So now I'm saying for if there is a null in fair, drop them, right? And this is the fair distribution, right? Now this is by gender, how many survived. As you can see, males only 18% survived, but females 74% survived because of the fact we just discussed. They first sent women and children onto the lifeboats. So there is a high chance women survived. Right. And again, value counts. If you see this, normalized equal to true is used at many points, and then that 100, that is what the scaling means, the scalars. Right. And this is passenger class. Looking at that, we see that passenger class 1, 60% survived, passenger class 2, 47%, but from 3, only 25%, less than 25%. Right. This is all up to here. It's everything is data analysis. We are looking at the data and we are observing and we are saying some facts. Nothing about data science. We didn't predict or we didn't train or anything. This is the first cell. That's where we are starting that. So if you remember, we have model selection. First, we have to split the data into train and test. Then pre-processing, we need to scale the data of different things, like the age is 0 to 100 and the fare can be what? Maybe $100 to $700 or $800. So we want to bring them all into equal scaling. So that's why we need a scaler. And in the previous example, we used min-max scaler, and this time we are using a standard scaler. And SVM is one of the algorithms that I mentioned in the first slide here, this support vector machine, right? So from the SVM, we are getting SVC. So what is that means? SVM is support vector machine and SVC is support vector classifier. And there is another one, SVR, support vector regressor. If we are doing a regression models, we need SVR. If we are doing a classification models, we need SVC. And this is a classification model because what we are predicting here, survived or not, only 2 outcomes, right? So that is it. And feature engineering, which I mentioned before. So we are saying only use these as the features, and this is the target as the survived column out of the columns that we have. But as you can see, passenger ID is not there in the features, right? Passenger ID, even though it is in numerical column, it's never used as a feature, right? Target is survived, that we know, because that is what we are trying to guess, whether a person can survive or not. Right, remaining, and this is important, one of the most important concept that we do usually in data science. A gender or embark or any other column which is in alphanumerics and which has a classification class of values, they are categorical values, they are not actually numerical values. So gender here, male or female, the sex is, we can give them 2 numerical values, but they are still not numerical values. That means 0 and 1, when we give the values, they don't have any significance. That 0 doesn't mean it is less than the 1. They both are equal. So in that case, we have to say it is a categorical feature, not a numerical feature. So how do we mention that? We have, if when we go down, I will show you. No, it should be somewhere here itself. gfsex.map, we are mapping to 0 and 1, embarked C, Q and S, 0, 1, 2, 3. Yeah, here. We are saying X is DF features, Y is DF target, and then we are splitting the X and Y. And this fit transform is to make sure we are scaling the values, all values into the same region. But that we did for test data, train data. Then for test data, we said transform. What is the difference? So for example, in the fair, there is 300 to 700, let's say dollars is the fair range. And fit transform now makes 300 as the 0, 700 as the 1, and based on what the values are, it takes different chunks between 0 to 1, it assigns different values like 0.1, 0.2, 0.3 like that until 1. But in transform, in the test data set, let's say we didn't get 300 to 700, we only got 400 to like 500, only 100 values are there in test. We have to transform those 400 to 500 also to the corresponding values of 400 to 500 in this fit transform. So that's what this second part does. Test data also we have to transform to the same scaling. So we are applying the same scaler for that. Then we are finally calling the model and the training. As I said, for every model, the fit method is there, which is called on the train data set. And we are calling on train scaled, right? And then we are predicting on test scaled. Okay, then we are doing for classification metrics, we need accuracy score. The remaining two are to understand the model, but accuracy score is most important one, like R2 score for regression models. Right, let's run this.
Sir,
There it is.
Sri Hari sir.
Yes, sir.
Yeah, better to wind up the session.
Sure then. Okay. All right. All right. So this here, logistic regression, this is what I mentioned originally. I kept it wrong here. This is supposed to be a classification algorithm. That's what we used here. And I'm not going to run through each cell, but I'm going to tell you something here. This is k-fold, that's fine. Grid search CV. So you remember the hyperparameter tuning I mentioned before. Here what I am saying is there are 5 values for model C, 0.1, 1, 10, 50 and 100, and model gamma, scale, auto and 3 more values. Kernels, RBF, poly and sigmoid, these are important only for SVC. Right, now grid search CV. So now you think of it as a matrix. Okay, C in one lane, gamma in another lane, and kernel in another lane. So out of that, now do the Cartesian product of all three. So for 3 different parameters, for each parameter there are multiple set of values. So the cross product of all of them, we want to run for the models for all these cross product and see which one gives us the best result, and we want to get that best result out into the best result output and save that, right? So this is what we did in the previous session as well, but we wrote that for loop in the nested for loops as well, and we did the testing. But this method does that all for us when we give the parameters, when we pass the parameters, and finally gives us the what is the best result as well. Okay, because I didn't run the cells above, I can't run this cell, so I'm leaving it here. You can download all this code from the link I pasted in this chart on GitHub, right? So, and then this is bike rentals is again another model. This is regression model, not classification. You can go through the session, go through the code. And if you have any doubts, please reach out to me. My email ID is there with Dr. Rambabu sir, right? If you have any questions, I'm open. I think we are now here. Okay. And there are no questions. There are 2 things. Either you understood everything or you understood nothing. So I hope the first one is correct, because that gives me a bit of smile.
Yes, sir.
Okay.
Okay, sir. Thank you very much, sir.
Thank you. Hope I didn't bore you. Bye.
Thank you very much, Mr. Srihari, sir, for the wonderful session. Your insights on real time analytics and practical applications were extremely useful and well received by the participants. On behalf of the ATAL FDP Organizing Committee, Right Management, and all the participants, we express our heartfelt thanks to you for your valuable contribution. Thank you once again.
Thank you. Thank you for bearing me. Bye.
We now move on to the session 10 of today's FTP. We are privileged to welcome our resource person, Dr. Sridhar, Associate Professor in the Department of Computer Science and Engineering at Geetham, Hyderabad. He holds a PhD from JNTK Kakinada and an MTech from Andhra University, Visakhapatnam. His areas of expertise include data science, machine learning, deep learning, and software engineering. Dr. Sridhar is certified in machine learning, Java, and Python and is a fully Wipro certified faculty in Java full stack development. He has published research papers in reputed IEEE and Scopus index journals and conferences. He also brings valuable industry experience as a solution leader in the data science domain, contributing to real world data driven solutions. We are delighted to have him with us today.
Uh, 1 minute, I will share. Is my voice audible? Dr. Rambabu, can you just?
Yeah. It's audible.
Yeah, thank you. Yeah, dear participants, good evening to one and all. So, because of few this thing technical glitches, I was unable to join in time. So sorry for that. So anyway, the first session I have also seen within couple of minutes that a wonderful session done by I think Sri Hari. Yeah. Now I will start my session, and before that I will share my screen. 1 second. Please confirm me whether my screen shared or not. Yes. Now I shared my screen.
Yes.
Right. Now is my screen which? Yeah. Thank you. Thank you. Bye. See, last class, what we have seen. 1 minute, I will open my VS Code editor, VS Code Visual Studio Code editor. Yes, this is my VS Code editor. Yes. Yes. Here in the last class, what we have seen. So in the last class, we have seen about how do we use two things. One is agent, right? That is agents related to Gemini, right? Last class, we have seen the agent related to here. See, I think my after clicking on chart window, 1 minute, something is AI code review. Why it is? Yes. See here, I selected the agents, right, in the last class. 1 minute, I will minimize this window so that yes. So how do we get to this window? See here, we have chart option is there. Whenever you will click on this thing chart option, see you will get this agents window. Right here, we have plenty of agents. Right. See what purpose we are using this agent window. Say right. For example, I want to something like implementing some website, or I want to integrate my website with your ML model, or I want to integrate my website with the DL model, or I want to integrate my database with the ML or DL or NLP model or data science. So you no need to write the code. Here you no need to write the code. Just to select the agent, right? Just ask the prompt. Just ask the prompt. See here we are having or not? Asking the prompt and edit the prompt. And so if already you were already asking the prompt, right? Here we have other things also we are having, right? After asking the prompt, right, we can edit the prompt, right? We can plan the prompt also, right? There are the things we are having in this window, right? This we can call it as the agent window, right? We have seen in the last class, right? After that, we have seen one extension we have seen. What is the extension name we have seen? See in GitHub Copilot, right? GitHub Copilot, this is the extension. I added this extension to my this one VS Code editor, right? Whenever you will just, for example, see here what I am doing. Click on next. Here Control yes, right? Save the file. Control S. See here my file name is, see what I am doing. Say for example, web app integration with ML. See what I am doing. See first select the Python. Right, we are under Python language, not in Java and other things. Python. Next one is just I'm showing you. Now we don't have the time to integrate all the things, right? Just I will show you how do we integrate whatever we want. Within seconds we can integrate, right? It may be integration with no, not required updates. Sorry, later. Why it is right? Just see here. Integrate. Sorry, integrate web application, integrate web app with ML model, right? ML model, just .py file, right? Click on save. See here, this is my file name. Now here in the comment window, see here in the comment window, what I say automatically got it or not. Integration of web application with machine learning. Click on tab. After that, click on next. See here from Flask, we know, right? See, for implementing web applications, we have some RESTful web apps we are having. What are the RESTful APIs? One is Flask, second one is Django, third one is Fast API, next one is Streamlit, right? Plenty of plenty of REST APIs we are having, right? This is one of the REST API, right? Flask. Again, just click on next, right? Next, click on next. See, this is import pickle, right? Again, click on next. We know what is the purpose of pickle. What it will do? It will save the model, right? Whatever the model we want to create, this pickle file convert into our not zeros and ones, right? It will convert into system understandable format and save it into our local disk. That's what we are using here, pickle file, right? After that, just again, see here where we are having these already know, right? See what is the purpose of load, what is the purpose of root, right? If you want to create the end points, so there are this is we can create any number of end points. This is my see here, this is my first root. What is the first root? 127.0.0.1. After that, predict, right? From here we can create our any number of end points, right? See here. Now click on next. Click on next. See here. Again. So sorry. Control Z. Click on next. See here. Again, tab. Click on next. Tab. Right. No. Sorry. Control Z. Right. Next one is Control Z. Right. Where we have here we are having, right? Again, click on tab. Why it is? No. Right. Click on tab. Right. Next one is enter. Right. No, it is asking something like update. That's what it is. Right. We are getting all these things. Right. We can delete one underscore main function. See here. See here. This is one web application. Right. Clear on what is the web application? What this web application? It is converting image to text. Right. See, image to text is one ML model. Right. Now we want now here what we are doing. We are integrate this ML model with something like Flask, right? Web application. So this is the way here. See here. Are you observing? Right? Since joining of the this call, this meeting, I didn't write the single code. Automatically, it is giving or not from the agent, right? From GitHub Copilot, I am getting. See, after that, after completion of this entire code, what I said in the last class, just copy this entire code and paste it into your Google Collaboratory, right? Yes, application will run, right? This is about VS Code editor with GitHub Copilot, right? It's same thing you can ask here also, right? Here also. See here, whatever the comment I am getting, this one, right? So here I'm copying this one. Here I'm copying this one. See here, just I'm copying this one. See, Control C. Now what I am doing? I am asking to my agent, right? Control V. Just ask, right? It is already in ask mode. Now just send. Working on it. See here. Here two variations we are having. One is from this thing GitHub Copilot. Second one is through agent, right? Through agent we are getting the code. See, whatever the thing we have seen, it is getting the code from GitHub Copilot. Right? Got it or not? See, these two ways we are having. See, one more thing, you can ask other LLMs also. Plenty of LLMs we are having, right? What is other LLM? For example, like ChatGPT. ChatGPT is LLM. Just ask to ChatGPT. ChatGPT. Right? It is giving or not? Yes, it is giving. Clear or not? See, perfectly it is giving. The code it is giving. Perfectly it is giving. It is still running. Right? This is the way. See, getting or not? See here. Import. Perfectly it is giving. Now what you will do after that? After getting the code, what is your responsibility? What is our responsibility? Whatever the code we are getting from either from agent or from something like GitHub Copilot, just copy and paste it into your collaboratory. Yes, your application will run. See here, see here. Got it or not? See here. Your responsibility is what? Just copy this entire code. Just copy this entire code. See here, if you want, anyway, the path issues, you may come or may not come, we don't know. But I'm copying this thing. Again, I'm going to my collaboratory. Say I'm going to collaboratory. See here, just coming here, paste it here. Now just run it this one. Just run it. Run it. Say here, running this one. Yeah, yes, it is running. See here, almost it is 50 lines code for integration of your web application with machine learning. In similar fashion, after completion of this thing, what you will do? Same thing, take any one database. It may be NoSQL database or SQL database. Any database you will take and integrate the database to ML model. After that, integrate all these things, all these three things. One is what? Web application. Second one is database. Third one is your MLDL or NLP model. Integrate all the things. Again, ask to either agent or GitHub Copilot. Right? See here, how much time it will take? Hardly seconds, not minutes. Right? Got it. Now what I am now this is clear. Now what I am doing? See, now just I was asking to my agent. I was asking something like convert image to text. Just now I have completed. Or else what I will do? Say I'm having the code here, right? For running, it will take time. Don't worry. See here. See here. For example, this is the code. This is the code. See here. No, not this one. See here. Now what I am doing? Same thing, right? Either you can use ChatGPT or something like your agent or collaborate. Say this one, GitHub Copilot. Control C. Now what I am doing? See, without writing any code, right? What I am doing? Whatever the code I got. So I got this code from ChatGPT, right? So here, what I am doing? Just I am running this one, right? This cell. Control V. Just run it. Just run it. Say the requirement already satisfied. The requirement, we will get the information like requirement already satisfied. Right? Maybe other cell it is running. That's what I will stop the other cells. I will stop the other cells. Yeah, just 5 minutes. Now I will stop the other cells. See, that's what here it is running. That's what whatever the information I pasted related to that installation. Now what I am doing, I will just stop. Yes. Yes. Now come back here. Come back here. Just run it. Right. Just run it here. Just run it to this one. Say, run this one now. Again, I think other cells also still running. That's what it is taking time. So whatever the cells running now, which is this is this one now. Why it is taking this much of time? Maybe it is restarting. Maybe some network glitches. I don't know. But this is the way. Try here after doing this one. Just whatever the code I got from ChatGPT, right? Just click on this one. This code I got from what is this code? This code intention is what? Say here myself I didn't write any single line. Right? Straight away whatever the code I got from either agent or ChatGPT or something like even Colab also, right? Colab also will provide. Colab is already integrated with AI, right? So many environments we are having for getting the code, right? Now it is running, it is installing. Right, requirement already satisfied. Just a few minutes back, I installed this one now. Right, now just click on this one, run this cell, run this cell. What we will get? The required library we installed, right? Pillow library we installed. Right, now see here, it is running, it is running, it is running, right? It is running. After that, see here. Now what we got? So finally we got, see, we got image or not? See what is, see what we got? See, we given what we provided. We provided something what? Right? What is the intention of this one? We provided some, this is about text to image. I provided my input prompt is what? Here my input prompt is temple. Clear or not? This is my text. Now I converted this text into something like image. Now beautiful image, we got it or not? Right? In similar fashion, we can convert image to text also. Image to text. Here in the prompt, you ask to ChatGPT or other LLM. Plenty of LLMs we are having. In the last class, we have seen how many LLMs we are having. 22 lakhs plus LLMs we are having, not thousands, not something like 1 lakh. 22 lakhs LLMs we are having. What is your responsibility? First, figuring out what is your problem, right? What is your research? What is your problem statement? What is your abstract? Figuring out exactly. After that, ask the correct prompt. This is more than enough for getting any code or whatever you want. Right? Now you tell me, is it a difficult task? No, it is very simple task. Even 10th class student also will ask. Here, we are not writing code, right? 10th class students not writing code. Even PhD holders, we are not writing code. MTech holder not writing code. BTech completed or BTech pursuing student, no, not writing any code. Just only ability is what? Ask the correct prompt, right? Based on your problem statement, ask the correct prompt. That is more than enough. Right? Now see here. Now this is one LLM, right? ChatGPT. Right. Now I will share other things. Right. This is the way. Right now, say what we have seen. How do we integrate? Right. This is the integration. I was stopping here. So because of running this thing, right? Whatever the query I was asking to agent, it has given the code or not? Yes. Your responsibility is what? Just after getting the code, copy and paste it into your collaboratory, right? After that, run the cell. If anything error you will get, again ask to your agent or ask to here something like your collaboratory, right? Collaboratory. See see here what we are having. What we are having. See here. You just click on here. What we are having here. See, generate with AI. Clear or not? Generate with AI. Whatever the error you got, right? Just ask to this one, generate with AI, right? It will give the suggestions, right? Right. You may get anything. You may get error, or due to some other issues, you may not able to get the output, right? Properly. Again, ask to collaboratory AI. It will generate the code, right? It will generate the code. You no need to go to again your GitHub Copilot, or you no need to go to your agent, or again you no need to go to your other LLMs. Since it has already integrated with your Colab is already integrated with AI, right? What is this one? Your Colab is integrated with Gemini, GE, right? Gemini, right? Gemini is the LLM or not? Yes. Now what I will do, I will show you one small PPT. It has plenty of information. It has. See here. See here. Now, what this PPT displaying? See, AI around you, right? We don't know how many times we are getting information from electronic gadgets or while driving the car, right? Knowingly or unknowingly, we are using the AI. We are getting the information from AI, right? We are looking into AI, knowingly or unknowingly, right? In many times, that's what I'm saying, that AI around you, the smart tech already in your pocket, right? For example, take mobile, right? It is smart, it may be smart watch, or it may be something like Apple iPhone or Android iPhone, sorry, Android phone, whatever it is, right? See, that's what I'm saying, that AI around you. Now see here in the second slide, see here, we are here, check traffic or find directions, right? Here, what it already having. Yes, AI is there. Because of that AI, it is giving the directions, right? Just ask, we want to move from Hyderabad to Rajahmundry, right? It will predict the routes and it will give you the exact route, right? This is nothing but AI or not? Yes, even restaurant also. If you want to move from your place to a restaurant, happily it will give the recommendations. Happily it will give the exact locations and exact directions, right? Because of AI. Next one is Chat GPT. Yes, we know, everyone knows the Chat GPT. Next one is whenever you will watch YouTube, automatically it is providing some recommendations or not, right? For example, you want to watch some technology, right? Whenever, right? See, you already started watching the technology. See, in the next day, immediately it will give the recommendation, right? It will give the recommendations, right? Based on your previous queries, right? It may be technology, or it may be science, or it may be something like arts, or it may be spicy, whatever it is, right? It will give the recommendation. Now, see here, even this thing also, right? See here, Google Lens, right? Everyone knows how do we use the Google Lens, right? Google Lens also, what it is, what it will do, right? It will whatever the query you want, right? Immediately it is giving or not, it is predicting, right? So that's what Google Lens is also implemented using the AI. Next one is here, face unlock and face lock and fingerprint. Yes, here also exact, right? It is using AI only. Next, Grammarly is there, right? In English, right? In Grammarly one website is there, right? Whenever you will type, right, automatically it will give the suggestions, automatically it will give the exact meaning words. It means that what, it's already built with the AI technology, right? Next one is what, see here, how to build app like Uber also, right? See, inside Uber, inside some softwares are there, right? It is giving Uber people getting something nearer locations or not. Whenever you will book the car, right, automatically, right, he will get the some notifications, right? So the behind what it has, yes, AI technology is there. Next one is Google Translation. If you want to translate from one language to other language, one language to multiple languages also possible. That's what it is, multilingual. Clear or not? Yes, Google having that capability, right? Next one, Facebook also, lot of LLMs we are having. They also will do the same thing. Next one is Amazon Bedrock. Amazon Bedrock, that is one. It has a lot of LLMs. It has, right? Amazon. So every vendor or every this thing, what I mean to say, organizations, they implemented their own LLMs. We have seen those LLMs in the last class in the Hugging Face, in that library, almost 22 lakhs LLMs we are having, nothing but transformers we are having, right? Fine. Next one, see here, from evening to from morning to evening, or evening to night, just ask to your something like your agent. So automatically it will schedule the things or not. Yes, it will schedule, right? It may be student, or it may be normal person, or it may be faculty, or it may be organization chairman, whoever, right? Just ask this thing, Alexa, or something like Apple Siri, or your own chatbot, right? They will give the complete schedule, right? Because of AI. See, next one is this is about this one. So next one is what? See here, AI is right. AI is already helping you without you notifying, right? We know that thing, right? Without noticing this thing, we already get a lot of information, right? Next one, see, knowingly or unknowingly, that's what I said. Knowingly or unknowingly, we got many notifications. From where we are getting the notifications? With the help of AI, right? That's what I said here. You have used AI 6 times today without even realizing it, right? So next one is next one is AI is hiding in right. See where this thing, for example, AI is hiding in plain sight. See here, what people think AI is futuristic. Clear or not? AI is futuristic. The reality, only 33% of the people know they use AI daily, but 70% of the actually use AI powered services, but they don't know actually, right? Multiple times they are using. So this is nothing but thumb rule, right? Right. So here we have lot of AI tools we are having, right? The best tools in the classroom, right? What are the tools we are having? So almost, see, ChatGPT we are using, Perplexity we are using, that AI Airtel related. Next one is see EPT, right? There are all plenty of tools. DALI, right? Next one is Spotify. Many things we are having. Grammarly, right? Canva. These are all the right good tools we are having, right? Whenever you will just ask natural language statement, immediately they will generate the whatever you want, right? If you want to generate text, yes, it will give the text. If you want to generate something like images, yes, they will generate the images, right? From where we have, see, one more thing I will tell you. So not only agents, not only GitHub Copilot, not only ChatGPT, right? We can generate the code with the help of generative AI, right? Here, generative AI in the sense what? OpenAI having thousands of thousands of LLMs we are having. What we required? Only API key. OpenAI API key is important. If you have the OpenAI API key, we can generate anything. We can generate anything. Even Google Gemini also, right? Just Google yes, AI Studio. Just go to Google AI Studio, right? Get the API key, right? Whatever you want, you can do it. Right here, for anything, it may be Google, it may be Open API. Open AI? What we required? API keys is required. Right? I will show you if the time permits. Just I am discussing with you. See, that's what generating whatever you want. Plenty of ways we are having. Right now, I'm just that's what I said. Not only agent. Agent is the nowadays people talking about agent. That's what I concentrated more on agents. Right? If you don't want agent, just go to use Gemini or use something like OpenAI. Right? So there it will provide something like some codes, right? Already existing codes. So just copy and paste it into your VS Code editor along with your API key. Yes, it will whatever you want it they will provide. Agreed or not? What I am saying? Yes. If you are not understanding, please let me know. At the end, I will share my email ID and contact number. You can call at any time. Now see here. Right, how AI models are built, we know, right? This is very fundamental things. I don't want to discuss this one. See here, future tools collect and organize all the best. See, this is about one more thing, become superhuman, right? If you are good at with all AI tools, you become like a superhuman, like Harman, right? So next one is see here, best AI tools for students. How many things we are having? Right, every student using this one, Google Translate. Grammarly also students are using. So in similar fashion, teachable machine, right? This is also from Google, right? Next one is auto draw, right? You no need to draw with something like your MS Word and Paint and all. No, not required. Auto draw is there. Automatically it will draw whatever you want, right? For your research purpose or for your MTech thesis purpose or BTech project purpose or internship purpose, whatever it is, right? Next one is see, we know, right? See, this is other thing. Quick draw. We have what we are having with Google, right? Quick draw dot with Google. This is also other AI tool for drawing the diagrams. Right here, you don't need to worry about this thing. For example, some people they are drawing in the sense what, right? They are using all these AI tools. That's what they are generating something like many things. So next one is Notebook LLM. What it is? It is also a Notebook LLM is also a implemented by Google. That's what I said. Notebook LLM is an AI tool by Google. Right? What it will do? Help you learn from your own notes. Clear or not? For example, you already written some notes. Just upload that notes into your Notebook LLM. What it will do? It will it may be PDF or whatever it is. It will read, right? It will read. You no need to read. So it will read and it will just your thing is just listen, right? So that's what it is, smart assistant. Whatever the notes you are having in the PDF or something like a docs, Google Doc or whatever it is, just upload into Notebook LLM, right? It will read, just you listen, that's all, right? You don't expect something like from your friend or something like from other colleagues. No, automatically it will read Notebook LLM, right? How do we go? This is the website we are having, notebookllm.google, notebookllm.google, right? Just if you are in the first time, just sign up. After that, sign in and log in. Right. So, right, clear this one where we are. This is about notebook LLM. So next one is Supreme.ai. What about this one? AI text student, right? Some memes regarding that we are having like this, right? Use this thing, Supreme AI, right? In similar fashion for Google Doc, everyone knows, right? Next one is see, like this, we have plenty of things we are having. See here, future tools and say we know, right? The difference between AI, ML, DL, and since almost 5 days, you people are came to know that what is AI, what is ML, what is DL, what is generative AI, right? The generative AI just 3-4 years back technology, right? Nowadays, people talking about what nowadays a lot of requirement is on agentic AI, right? That's what in the extra days class also straight away. I see one more thing I will tell you. Nowadays, I will tell you, no person using TensorFlow, no person using PyTorch, right? No. The reason is what we have advanced Lang graph is there, right? Lang chain is there, right? There are all the platforms, right? For agentic AI, right? RAG is there, right? Retrieval augmented generation, right? If you are good at with the RAG, if you are good at with the RAG architecture, right? If you are good at with the Lang chain architecture, if you are good at with the Lang graph, right? We can do the miracle, right? For implementing agentic AI project, what we required, just preliminary information is required, right? Just you should know about LLM's story. I'm not asking you just to spend something like hours and days. No, just to know the what are the LLMs, what each LLM will do. That information is more than enough. After that, just to concentrate on prompt engineering, right? Prompt engineering. If you are good at with LLMs and prompt engineering, we can happily adopt agentic AI. We can happily implement agentic AI applications, right? So here in the diagram, just I mentioned here, right? This is a old thing, generative AI and deep learning, right? Yes, for moving into this thing AI, we should know these fundamentals, right? This is also now say here agentic AI we have or not a software that can perceive, reason, and act autonomously. That's what I'm saying, autonomously, not something like intervention, right? We are not interacting, right? Autonomously, it will do any task, whatever the task you will provide. It may be multi-modal task or converting image to text, text to image, or image to something like audio to video to text. Yes, whatever you want, just ask to agent will provide the complete code. After that, you can integrate the entire thing with your any endpoint in the sense applications, right? Now companies are doing this thing only, right? They already know the endpoints, right? What they required a code for integrating these two endpoints are more than two endpoints. Endpoints in the sense what? Nothing but websites, right? Amazon having thousands of URLs it has, right? As a agentic AI person, what you will do, right? Once create the code, when developing the code related to this thing, just integrate all these endpoints with the help of agentic AI. That's what, right? See, next one is again all the things, right? So plenty of the even self-driving car also, people even self-driving car or Siri or Microsoft Cortana and Amazon what is this one, Amazon, what we are having, tell me, you know, right? Every people using Alexa. Don't forget these personal assistants. Now clear, recommendation system project, right? Everything, whatever the things we are having, recommendation system or sentiment analysis or smart. See, everything we can implement with the help of not only in CSC field, in civil engineering, electronic, bioinformatics, biotechnology, every field nowadays people using agentic AI. That's what agentic AI having a lot of requirement in the coming 2026. Agentic AI is 2025 technology, right? If you want to put something like fake experience, they will they laugh, right? The recruiter will get laugh. So that's what don't put the fake experience for agentic AI. If you want to put the fake experience for data science or something like generative AI, yes, it is acceptable. right? So this is about this thing, fraud detection and everything. Now clear? See, there are non-intelligent systems, right? Companies using deep learning nowadays. There are just I'm giving the insights, right? Now got it? Everything here, right? This is about now. Do you know how do we get the API key? API key, for example, see here. See here. Just now, or else 1 minute. I will show you how do we get the API key. API key. What API key? What API key? Gemini API key. Just Google it here, Google Studio AI, right? Google Studio AI, right? Google Studio AI. Right here or not? We are getting or not? See, aistudio.google.com Gemini API. Right now, just get a Gemini API key. See here. Just click on this one. Here, get API key is there. Right. This is about how do we get the API key from Google. Right. What is the model? Gemini. Right. This is the way we can get the API key. Now, in similar fashion, now clear this one, all of you. Right. Now, once getting the API key, you can use happily. You can use see here API key. Clear or not? API key. Right. It is see here default project here API quick start and create API key. Just click on this one right here. So this is the way. Name your name. Just provide your details and all. Automatically it will give the key. Right. This is the way we can get the key. In similar fashion, how do we get the OpenAI API key? Now all of you understood right what I am talking. Right. Next one is see here. Just go to Google and just click on OpenAI. Right. OpenAI is organization. Google is also an organization, right? OpenAI API key. See here. Just click on this one. See here. OpenAI.com index OpenAI OpenAI. Just click on this one. See here. What we are having here, research safety for business developers and ChatGPT, many things we are having, right? Here, explore the API, right? Click on this one, explore the API. Click on this one. From which what you will get? You will get the key or not? Yes, start building. Right, next click on start building. Right, this is the way we can get the API of OpenAI. Right, this is the way we can get any API. Here also, how many days it will active? Only probably 1 year, or based on your work. After that, see API, if he is asking something like price, once 1 year will complete, so he will ask the something like price. See, this is the price, right? For 1 million tokens, something like $1.70, almost $2. Right here, GPT 5.2, GPT 5.2 Pro, GPT 5 Mini. Right, we have seen, right? GPT 5 Agent Mini we have seen in our here Google in here. See here, GPT 5 Mini. It is now free. How long it will free? Probably till 1 year. After that, immediately they will ask the something like price or money. Right? Now got it what I'm discussing. Now 1 minute. So I'm having other things also, but you through this one, I will 1 minute. I will show you how do we. For example, I will go to my this one. See here. I already 1 minute. I will upload a few files and show you. So how do we utilize the multi GPUs and how do we utilize the multi agent, right? How do we utilize the, see all these things, clear or not? How many things? Just 4 files, just what I am doing, I'm opening, I'm upload them into my environment, right? My Google Collaborator. See here, uploaded or not? Yes, uploaded, right? Okay, what did you say? Ensure that your files are saved elsewhere. this runtimes files will be deleted when you are okay, no problem. After that deletion, it's not the issue. Now see here, just open this thing, open notebook, right? What is my notebook? This one, right? Plenty of things we are having. One is using LangChain. I already said, right? Say that's what you don't go to something like PyTorch. You don't go to something like TensorFlow, right? Just go to advanced frameworks like RAG, like LangChain, like LangGraph, right? Nowadays, people are using all these things in the real world, right? See here, just now I uploaded how many this thing, many things I uploaded. See, anyway, I will open this one in front of you. It's already somewhere else. One minute. Locate open notebook, upload notebook, and open notebook. Right, open notebook. Yes. So in similar fashion, so if you want, I will share the code. Here we are having, say, understanding agents in LangChain. I already said, right? Right? You don't go for your, I already discussed with Professor Rambabu regarding this one, right? You habituate to use LangChain, you habituate to use RAG, you habituate to use LangGraph, right? There is no use of using TensorFlow and PyTorch. See here, the material having something like what is agent, core components of agent. See, I already said or not? The core components of agent, right? I already said, right? The backbone of agent is LLM, large language model. Next one is prompt. If you are good at with these two things, we can happily use the agents. See here in the here notebook also they said LLM and prompt template, prompt engineering, right? How do we ask the query? That is nothing but a prompt, right? Here now why use agents? Here types of agents in LangChain, and right in LangChain, right? Tools integration, right? There are all the tools we are for database and all the things. We have many tools we are having, right? The workflow, right? How do we receive the user query? Think and plan. They're all who will do, LLMs will do, right? Next one is benefits of LangChain, right? After building the agents. Next example use cases, research assistant, data analyst, math solver, knowledge chatbot. For everything we can use the agents, right? Say for regarding that what we required, Gemini API key is required. That's what here Google API Studio, right? How do we get the API key? Just Google it in the Google search bar, Google API key, right? It will redirect to Google AI Studio. From there, you just create the API key. After that, get the API key, right? Where you will copy and paste it that into where you will copy and paste it in your .env file, right? Just create the .env file and just paste it into your API key, your Gemini API key in that env file, right? See here the same thing. Pip install LangChain. Next thing. LangChain Google Gen AI, pip install Google Generative AI, right? Python.env, right? Once installing all the things, right? Whatever the task you want, you can do it. Say here, right? See here. Next one is what? See here, what we are doing? We are using LangChain Olama. This is nothing but what? Facebook. If you want to use Google LLMs also, we have seen in the last class or not? What are the Google LLM, right? BERT, BGRT, bidirectional encoder representational transformers. How many BERT models we are having? 46,000 plus BERT models we are having. Clear or not? 46,000. Use any one of the model based on your NLP task. Clear or not? Right. So now here we are using Facebook LLM. That is your wish. Right. See here. This is the way we can right install everything related to this one. Right. Here this one. See, this is nothing but installation only. See here. If you want to know the version, Like this, we can know the version, LangChain version, right? See, this is the way, right? See, what is the, after that, you just provide some code. See, this is not user-defined code. It's already built-in code. What I am doing, just I'm copy and paste it into your Google Collaboratory. What is LLM? This is the name, Gemini 2.5 Flash. This is the model I'm using. Right here, temperature in the sense what? So it is something like a probability, right? The response related thing. Right here, chart, Google, generative AI, right? This is existing class, right? Here, they are all the parameters we are passing, right? This is the agent, this is the agent, this is the model, this is the agent, right? This is the response, right? Next, after that, we are printing that response, right? You just tell me, is it difficult or it is not difficult? It is very simple using LangGraph, using something like particular LLM, right? Just I'm copying and copy. You just Google it. You will get, or ask your agent. Immediately he will give the agent only, right? Right. We know how do we ask the this query to agent. Agent will give this entire code, right? Creating research agent, right? We have some applications, right? Right. Research agent. So 4 agents, chatbot agent, right? Next one is restaurant agent, weather agent. Next one is if you want to implement application related to your engineering college, just ask, it will give the code. Only thing is after getting the code, you just modify according to your requirement. That's all, right? Now with this, I'm concluding this one. Having any queries, you just noted down my number or my mail ID. Call to any time and text me at any time and email me at any time. I will respond. I will respond. This is multiple tools we are having for chatbot, right? My name is Dr. Jinka Sridhar, working as associate professor in the Geetham University. My contact number is here. I am typing. Here I am typing. Where here I will type. Yeah. Now notebook. Right. See here. Notebook plus plus also. You can use either notebook or notebook plus plus. Already open a notebook, right? I will enlarge the screen. 8790423564 is my contact number, right? Control plus plus, right? Next one is my mail ID is Sridhar Jinka 80, right? SREEDHARJINKA, Sridhar Jinka 80 @gmail.com, right? Approach at any time, no problem. Right, Sridhar Jinka 80. This is my mail ID. This is my contact number. So with this, shall I conclude the session now, Professor Rambabu?
Okay.
Yeah. Thank you.
Dear participants,
Rambabu.
you have
Thank you.
any queries? Lavanya?
So,
Well, you can conclude.
thank you very much, Dr. Sridhar, for the wonderful session. Your insights on real time analytics and practical applications were extremely useful and well received by the participants. On behalf of the ATAL FTP Organizing Committee, Right Management, and all participants, we express our heartfelt thanks to you for the valuable contribution. Thank you once again.
Yeah.
Today's session is going to end, so I would like to thank everyone whoever joined the session. There is small intimation for all the participants. First one, tomorrow we have 3 sessions. Secondly, online test and feedback. Third one was valedictory session. You may all now leave the session and expecting you to attend tomorrow's session by sharp 2 p.m. Thank you.
Yeah, Professor Rambabu, shall I leave now?
Thank you, Sridhar, once again.
Yeah. Thank you. Yeah, you are welcome. Bye.
Yeah.
Should I?